The way that aircraft are typically moved is it's a very manual process. There's typically a lot of people who are walking around the aircraft that are monitoring everything. There are a couple of systems that exist to help those people communicate, but there was really nothing out there that helped to expedite the process or help the communication in real time. My name's Andrew Mokes, one of the co-founders of Evitado Technologies. And at Evitado, we're developing autonomous systems to help automate airport operations.
We found a pain point in the airport ground operations space, which was aircraft collisions on the ground. And we found that actually this market is very underserved for technology to assist the humans doing the job.
What was really important for us when we started developing was to create a tool that the operators could easily implement into their normal working operations.
So our system influences safety because the job of the ground handler or the aircraft mover is not always so easy. They do it at dark at nighttime, they do it in inclement weather, they're moving different aircraft sizes. So our system helps give them an extra sense of what's going on around them, not dependent on any human distractions that may exist. Part of what also makes Evitado innovative is the fact that it is really one of the first times that these operators have an opportunity to use technology in this space. And now they have a real technological solution that they can turn to and say, we have this to add to our operations to make it more safe or more efficient.
You know, safety within the aviation industry is top priority for any company. And that was the biggest shock then for Alex and I, that it's so easy to damage an aircraft during towing. So by implementing new tech, by implementing certain automation processes, you increase safety across the board.
The ability for our system to help them make a real-time decision to avoid a potential incident adds that extra layer of safety. So the scope of this problem is large and it's also global. Consider that there's between 20 and 40 million flights departing each year, and an incident is bound to happen in 1 in every 1,000 departures.
What we needed to be able to do with the sensor itself was be able to identify the aircraft in relation to everything around the aircraft, and we really felt that a three-dimensional point cloud was the best way to do that.
This can help them avoid accidents of colliding the aircraft into infrastructure or other vehicles. And finally, it adds some data and digitization to what they're doing, giving them an overview of those movements over time. With the Ouster sensor, in combination with being able to track where the aircraft is down to centimeters of level of accuracy, we can give a real-time alert to the operator if a potential collision is about to happen.
It was beneficial to have a three-dimensional sensor over a two-dimensional sensor because of the environment that we were trying to work in. Aircraft are three-dimensional objects, they're quite complex shapes, and so it was really important for us to be able to differentiate, between the wingtip and a box in the hangar, for example. We needed to see that three-dimensional change or three-dimensional distance in order to be able to provide a useful solution for the operators. Yeah, we at Evitado, we see that the airport environment it's a controlled environment, it's ripe for automation, and if we're able to implement automation for pushbacks, for cargo handling, for loading, unloading, for jetway movements, I really think it'll be a big game changer for travel in the future.